Welcome back. Let's talk about 2.6. Okay, a scatter plot is a graph of a set of data pairs x, y. You just graph what you see in your ordered pairs. If y tends to increase in a linear fashion as x increases, then the data have a positive correlation. Correlation refers to a linear relationship. So if the slope of the line that would go through the data would be positive, then there's a positive correlation. And so that means that as x gets bigger, y gets bigger. And conversely, as x gets smaller, y gets smaller. Now, if the data are such that if you drew a line through the middle of it, the line would have a negative slope, then you've got a negative correlation. So if y tends to decrease in a linear fashion as x increases, then the data have a negative correlation. If the graph shows no obvious pattern, then the data have approximately no correlation, or a correlation very close to zero. Okay, a correlation of zero means that you don't have a linear pattern at all. In fact, you probably have just a big cloud of data where knowing anything about x doesn't really tell you anything about y. A best fitting line is the line that lies as close as possible to all the data points. Now, we're not going to actually calculate the best line of fit. It's called the least squares regression line, and it takes every point into account. We're going to practice using skills that we have at this point in Algebra 2 by by drawing a line that represents the data well and picking out 2 points on that line. They might be data points, they might not be, but they need to be 2 points on that line, and then from there we're going to write the equation of the line. So when you're approximating a best fitting line, you want to draw a scatter plot of the data, and that'll tell you some things. It'll tell you if a linear model is even reasonable. It will tell you whether you should have a positive correlation and a positive slope or a negative correlation. So a negative slope, it's going to give you really good information. Then you're going to sketch the line that appears to follow most closely the trend given by the data points. There should be about as many points above the line as below it, because they're not going to hit the line exactly most of the time. Most real world data is a little messier than that. Okay, so about half the point should be above it, about half should be below it. Choose 2 points on the line. Now they need to come from the line. If they happen to be data points, that's great. If not, that's fine too, but they need to come from the line, and estimate the coordinates of each point. Write an equation of the line that passes through the 2 points from step 3. So you're going to know 2 points, so you'll use them to find the slope, and then you'll use that slope in one of the points to start your equation in point-slope form, and then transform it to slope-intercept form. Okay, the table below gives the number of people who attended each of the first 7 football games of the season. Approximate the best fitting line for the data. So X is the game number. You can see you got 1 through 7, and then Y is the number of people. And it starts with 722 and it ends with 897. Okay, so first thing we're going to do, our first step is to draw the scatter plot, and then we're going to sketch the best fit line. Now, I usually go ahead and name my plot, so I would probably have football game attendance written across the top. But it's sufficient to label the 2 axes, but you have to do that. You have to label them for what they are, and then you have to draw in your scale. So on the horizontal, because that's our X value, we have the football game. So we have 0, 1, 2, 3, 4, 5, 6, 7. And then on the vertical, you'll notice that there's a little squiggle there that indicates that there is part of the axis is missing just because there's no data values there. So we're skipping up to 650, 700, 750, 800, 850, 900. Now, when you're scaling your axes like that, you want to look and make sure that you've got a reasonable scale, that the minimum value that you show is smaller than the minimum value on the data. The smallest Y value is 722, so 650 is sufficiently small, and that the largest data value is larger than the biggest value in the data. The biggest value in the data is 897, and so 900 is sufficiently large. And the same thing we should check for our horizontal axis. Is a little easier. 0 is smaller than 1, and then we've got 7 on there, and that's the biggest X value we need. Okay, then we want to sketch in the best fit line, the line that fits the data the best, and you want to see that you've got about the same number above as below it, so you can look and see you've got 2 above, and 2-ish below. That 1 is kind of below but kind of touching it. So that's a really good fit. Then we want to choose point on the line. From the scatter plot shown, you might choose 1, 722, which is actually one of the data points, and then 2, 750, which is not one of the data points. The whole point is that you want 2 points that are from the line. Step 4, write an equation of the line. The line that passes through the 2 points has a slope of m equals, we're doing y2 minus y1 over x2 minus x1. So 750 minus 722 over 2 minus 1 is 28 over 1, which is 28. And then we use point slope form to write the equation. So y minus y1 equals m times x minus x1. So let's see. Y1 is 722, x1 is 1, and our slope is 28. So we're going to have y minus 722 equals 28 times the quantity x minus 1. We've got to distribute the 28, and so we get y minus 722 equals 28x minus 28. And then we add the 722, and we get y equals 28x plus 694. So an approximation of the best fitting line is y equals 28x plus 694. So what that means is that that slope of 28, that means that on average for each football game, we expect 28 extra people approximately to be added to attendance. Now the data points don't fall exactly on the line, so it's not going to be 28 every time, but it's going to average out to be about 28 more people at every football game. Now the plus 694, in theory, that's what would happen when you plug in 0. But if you think about it, the 0th football game doesn't make sense. It's great that there would be 694 people there, but there's no such thing as the 0th football game. It just gets us started at a point that our slope works for our situation. Use the equation of the line of best fit from example 2 to predict the number of people that will attend the 10th football game. So we're going to let x equal 10 and see what we predict the attendance to be. And this would be important, say, for the concessions people to know so they can make sure they have enough food, make sure you've got enough programs, make sure you have enough seating. Because you are predicting the 10th game, substitute 10 for x in the equation from example 2. Y equals 28x plus 694 equals 28 times 10 plus 694 gives you 974. You can predict that 974 people will attend the 10th football game. Okay, guys, that is it. You've got some problems to try on your own now. Make sure you get those done and bring those to class with you. And I will check that you have your notes, and then we will go over the problems to try on your own, and we will get you started on your rounds. Have a good evening, and I will see you later. Bye-bye.